No? All right, so let's get this done. Okay, so today is, and this is literally what it is, Cpctc. It is one of my favorite days of the year. Okay, so today I just need you to get into your heads, even though I have a headache today. I'm still going to probably get a little too excited because I love this lesson so much. Okay, and one thing is today is going to be a requirement that all participate. Are you guys with me on that? Everyone has to participate today, because if not, you're not going to have it memorized. You're not going to have as much fun. So you just have to participate and have a little fun. Okay? So kind of ish. So with this one, we want to use the idea that we can prove triangles congruent. And it's really using the idea of the definition of congruent polygons to help us out. But first, we should know 5 different ways of proving triangles congruent. Raise your hand if you know the 5 different ways of proving triangles congruent. I think if you could tell me, just list the 5 different ways. Who thinks they have this? Okay, Hannah, go for it.
Side, 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 side.
Hold on. I have to write this down. Side, 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 congruent.
Side, side.
All right, guys, what am I writing after those? Congruent symbols, please do so as well. Angle, angle, side congruence, great. Angle, side, angle congruence. And, all right, those are the only ways you are going to prove triangles congruent. Only ways. And so if you got those 5 down, you got it easy. Yes, sir.
What about side, side, side?
I don't think you even need to know that, because you only need 3 things. So why would I want 5?
Well, like you said.
Yeah, but why would you do that to yourself? Like side, side, angle, angle, angle. That's like so much work. Connor, the whole point of these is to save us from doing that much work. Okay, that's the whole point of it. But you just need those 5 things, and then we're going to go a step further. Now, I need you guys to go back for a moment. Remember the definition of congruent polygons or triangles. It says 2 polygons are congruent. We could put in the words 2 triangles, right? If and only if the corresponding sides and the corresponding angles are what? Congruent. So the fact is, we only ever have to show 3 things. Does that mean the rest of the stuff should be congruent as well? And I could use that for other things. So that's literally what we're going to do, is we're going to sit there and say, oh, because these triangles are congruent, I know this other stuff is true. And so instead of writing out our definition for congruent polygons, we give ourselves a little bit of an abbreviation. And that abbreviation is literally Cpctc. Now, here's what it says. And you're all going to have it memorized before we go further, period. Okay? We're going to have it memorized. All right, the first C stands for corresponding. So corresponding, and P stands for parts of congruent. T stands for, guess what shape? A profound moment, wasn't it? All right, triangles are congruent. Now, basically, that's taking the idea of definition of congruent polygons, where everything has to matchy-matchy, into like a really quick little phrase, right? That we know if triangles are congruent, we know corresponding parts of congruent triangles are congruent, correct? All right, guys, the best way to memorize something is to say it what? Out loud. Yeah, write it down, say it out loud, whatever. So we're going to do this, and so this is how it's going to go. I'm going to go, okay, class. What does Cpctc mean? And then I'll go, go. Are you guys ready with me? All right. Now that you know the prompting, everyone's ready to go. Class, what does Cpctc stand for? Go.
Corresponding parts of congruent triangles are congruent.
You said that as if you're doing a response reading in church. People, that's boring, okay? There's a little bit more than that. You guys know what I'm talking about, right? When you do this in church. So, you are in Greg Richardson's classroom. Guys, am I ever completely boring like that? Do I get excited a little bit about math?
Yes.
You need to get there too. Yes, I do. You need to get there too. So when you say this, let's have a little bit more emotion and feeling behind this, okay? Because this is it that you have to learn. This is like one of the shortest like learning moments in this class. Like, when's the last time you've had like one thing in here? Never. Okay, so let's get into this. All right, class. What is Cpctc? Go.
Corresponding parts of congruent triangles are congruent.
I'm almost positive that recorded. That was very good. So that was good. There was a little bit of more of emotion, but you know what? I know a lot of you are in MTP. Correct, class? And I know you're way more dramatic than when you have. There should be, I mean, gut-wrenching emotion should be happening at this point, okay? So, with this one, someone start crying, nice. All right, so let's try this one more time, and I want true, no church stuff, okay? We're talking about true emotions. Well, unless you're like a black gospel church in there, woo-hoo, they praise the Lord, okay? I'm just telling you. All right, so, guys, what does Cpctc stand for? Go.
Corresponding parts of congruent triangles are congruent.
That was almost answered. You all work together as a group. I feel like I'm in choir class right now. This is getting better. All right, so let's see if we can do this if I point at your row. Okay, at your row. Okay, guys, this is not that hard. So let's do the row. Okay, not going across this way, like coming at me, all right? My columns. Got it? Are you guys with the columns? Are you guys good? Okay. Maybe you can do it around. Okay. All right, let's try this. Are you guys ready?
No, wait.
You be ready to watch the point. You got to know this, okay? You got to be ready. Guys, what does Cpct stand for?
Corresponding parts of
You guys are bad. Okay, watch your point. You guys are not good at reading or following directions. This is bad. Okay. All right, are you guys ready to go?
Yeah, I'm ready.
Are you with me? Calling. All right, are you guys, all right. Okay. Those of you, if you got parts, okay, listen to me. If you have corresponding, you're kind of boring. Okay, let's go there. Parts, easy. But those of you who say, you have to say of congruent or this just does not go well, okay? And then the last group, you have to say what? Are congruent. Are you guys with me on that? All right, so see if we can do this. Are you guys ready? All right, guys. What does Cpct stand for?
corresponding parts of congruent
Triangles are congruent.
I should go together here. Oh, wait. These guys got lonely. All right, here we go. Let's see if you can do it. Watch the finger this time. You guys ready? Guys, what does Cpct stand for?
Corresponding
The finger's still there, people.
parts
triangles are congruent.
That's actually not too bad. All right. Now, everyone turn around. Turn around. Turn around. Okay. Do not look at your paper. That's cheating. Turn around. All right. I want the whole group this time. I want the whole group. Class, what does Cpctc stand for? Go.
Corresponding parts of congruent triangles are congruent.
That was actually not too bad. Who thinks they can do a solo?
Oh.
Oh, yeah, so, okay, I have two people volunteer. All right, Connor, stand up. What is CP? I can't walk. All right, what is CP? You have to stand up. And without looking, actually, you need to turn this way. You have to turn this way because you can't see anything. All right, what does Cpctc stand for? Go.
Corresponding parts of congruent angles are congruent.
Whoa, close. He said angles. All right, one more time. Okay. All right, Connor, you can redeem yourself. What does Cpctc stand for?
Corresponding parts of congruent triangles.
Very good. All right, good. Excellent. That's impressive. All right. Gloria Grace said she was going to go for it.
Corresponding parts of congruent triangles are congruent.
Great. Good job. Okay. Now, anytime I ask in the next century, okay, which means when you come back from homecoming sometime when you're visiting back as alumni, I might ask you what Cpct stands for, and you will always tell me what?
Corresponding parts of congruent triangles are congruent.
You went to instant church mode again, people. Come on, instant church mode. All right, don't worry, you have plenty of time today to say this yet. Not too bad, but how many of you have it memorized now? Love me later. I know, this is great, you got it memorized. And it was a little bit of fun too, wasn't it? I didn't dance this year, that's when it's really good. All right, let's go here. Example 1. Says A and B are on the edges of a ravine. What is, now by the way, notation's been really poor lately. How does that read right there? What is what? It actually says what is the length of segment AB is how that reads. All right? So if I'm asking for the length and there's no bar there, please quit putting the bar with the equal sign, okay? So with this one, I want you to think about what's really happening. In order to know what the length of segment AB is, don't I need to know what it's congruent to? So look at this one for me real quick. Guys, what do I have? Do I have a pair of congruent sides right there? It does not want to come with me today. Here we go. So aren't these two congruent? So I have a pair of sides. Do I have another pair of sides? Okay. So how many pairs of corresponding sides do I have? Do I have anything else that's congruent in those two triangles? The vertical angles. Great. So, do you guys agree with me then? And I'm putting the y behind this. Is that all right? We're writing down the y, but that's not everything you have to do, but this is the y. All right. So with that being the case, what do I know about these two triangles? They're congruent by side angle side. If those two triangles are congruent, what's the length of segment AB? Yeah. Doesn't that make sense? It's 18 miles. Because if the triangles are congruent, don't the corresponding parts have to be congruent? So that's why. So here's how we're going to do it. So I'm going to write the y down. And you guys are going to want to do this just so it kind of clicks in your head. But if I don't ask why, you don't have to explain why otherwise. It's just so you have it. So since the two triangles are congruent by side angle side congruence, we know segment AB and the other corresponding side are congruent by what? Okay. By the way, what does Cpct stand for? Go.
Corresponding parts of congruent triangles are congruent.
You had way more emotion earlier, I'm just saying, but thank you for saying it. So we know that's the case. So logically, that means I can automatically mark my third sides congruent. We know the length of segment AB is 18 miles. Notice, because I know they're congruent, I can keep going. Now guys, could I even talk about congruent angles in this diagram? Yeah, I can even show other pairs of congruent angles as well. Excellent, that's what I want to hear. Now, the next part is kind of like we're doing mini proofs, okay? But we're not actually doing the proof. I know that just kind of confused you. We're doing mini proofs, but we're not actually doing the proof. In your head, and this is going to be a problem like this on your test, basically, I want you to prove to me or show me that these are true, okay? We want to get there. But the thing is, honestly, I don't want to take the whole time and do the whole long proof. So it's kind of like what we did yesterday. We combined it. I want you to be able to look at the triangles and tell me if they're congruent or not. So look at number one. Are those two triangles congruent? By what reason? All right, awesome. So that's what you're going to tell me first. You're going to sit there and say, by side angle side congruence, triangle ADB is congruent to triangle. If I said ADB, which it has to match up to? CDB, awesome. Because we matchy-matchy, right? Vertices have to match up. So we know that is true. Since those triangles are true, we know angle A is congruent to angle C by what reason? That's right on. Holly, what is it again? Which stands for? Go.
Corresponding parts of congruent triangles are congruent.
Do you see how it's doing the exact same thing but going what? One more step. We're just going one more step. All right, so let's look at number two. I'm trying to prove the length of segment HE is congruent to the length of segment FG. How would I do that? All right, I heard it. Perfect. By angle, side angle, because of the reflexive, right? So by angle side angle congruence, triangle EFH is congruent to triangle. If we go EFH, we're going to have to go GHF, right? So what do we know about our two segments? They're congruent. So segment HE is congruent to segment FG by Christopher. Which one? What's my reason for it?
Cpctc.
Very good. Cpctc, which means what, friends? Go.
Corresponding parts.
That was not good. Guys, what does Cpctc stand for? Go.
Corresponding parts of congruent triangles are congruent.
Now you're rocking. That's much better. Okay. Now, talk to me about the next one. Are those triangles congruent? What reason? On number 3. HL. We can't, remember, if you end up spelling side, side, angle, you pause and look to see what type of triangle. If it's a right triangle, then it turns into what? Hypotenuse leg, and then it's okay. So you gotta remember, be careful. Side, side, angle does not work except for in one lonely instance, and that's hypotenuse leg. All right, so let's say that then. By hypotenuse leg congruence, triangle, let's go, bless you, the triangle, bless you, I don't think it's really the triangle, but anyway, triangle JLK is congruent to triangle. If I go JLK, we're gonna have to go which one? P. So we know angle K is congruent to angle P by what reason, Josh? What do we get? What reason? So the triangles are congruent by hypotenuse leg congruence. So how do I know that K and P are congruent?
Cpctc.
Right on, exactly. It's pretty simple. But here's the thing. Not once have I ever used it before they're congruent, have I? Only when is it used? After. Okay, you guys do the next two. Go. You do 4 and 5. Yeah, look at number 4. How'd you guys do on 4 and 5? Did they make sense? And you guys matched your vertices carefully, right? But here's the thing on number 4. You honestly don't need to prove the triangle's congruent to do this one. Guys, how many pairs of congruent angles did you have? So what do you know about the third? They're congruent to each other. So could I do this with an alternate way? Instead of doing that, I probably could have done it in like 2 steps. Can I use the third angle theorem? And honestly, this is just making sure you're learning how to do congruent triangles and stuff with it. But if you saw the third angle theorem, would I even want you to waste your time proving the triangle is congruent? No. So just know you could have done that more than one way. It was just trying to get the point across. With me on that so far? All right, awesome. All right, I think this one will be pretty easy on here. You guys are getting good at proofs, so you do the next steps. You fill it in on your own as well. Do we need a little more time? A little bit more? Okay. Good stuff so far. What do you think I want the very last reason to be? Yeah, Cpctc. This needs to be your last reason. When can you do Cpctc? Only after what? Congruent triangles. So what has to be the step before that? Congruent triangles. Notice I'm almost working backwards here. Yeah, because you can never use corresponding parts of congruent triangles being congruent unless the triangles are congruent. So that's basically my goal to get there. Notice the very first step. I tell you the triangles are right triangles. right away what starts kind of going in your head? You might be using what? HL, right? Hypotenuse leg. Exactly. So if that's the case, we know it's given. Wonderful. I don't have to worry about that. The very next thing they tell you is UX is congruent to UV, and everyone knows that's what? Given, so we have it marked. Isn't that our H, our hypotenuse? And then we get UW is congruent to UW, which is what? Reflexive. That's our leg. It's reflexive property. All right, so I have two triangles that are what? Congruent. And then make sure you just match these up. Like I did UWX is congruent to triangle. If I go UWX, I have to go U what? WV. And that's going to be HL congruence. Notice next step is then your corresponding parts of congruent triangles. Never put Cpctc before. It always goes where? After. Yes, ma'am.
So when you put the hypotenuse leg congruence, can you also say like or side angle, or does
No,
it really...
no, because we're not proving the angle's congruent and it wouldn't work. Because that's when it's the ambiguous case. But because of right triangles, we know they're limited because of the right angle. That's the only time we can't. So it has to be hypotenuse leg. Thank you, though. All right, now guys, I put tons of proofs on here because honestly, I want you guys to be able to rock it. And I think you guys can do a good job of this. I think that you've been doing proofs really well so far in this chapter. But let's just crank these through really quick and see how you're going to do. So let's make our only two columns here. So here's my statements. Here's my reason side. And guys, one thing you need to do that I still feel like is a lacking thing that needs to improve in here, mark up your what? Mark them up. All right, so let's go with this one. Guys, what are we going to put down first? Just put the very first given? Okay, so segment YW bisects segment XZ. If I give you a segment bisector, what do you guys give me? Two congruent segments. Which two? Yep, and ZW, right? There's my two congruent segments. Definition of a segment bisector. Awesome. Now what? Yeah, we're going to go back to our given. So I got segment XY is congruent to segment YZ. That's given. Going to put it on here. Guys, what do I have so far? Two sides. So I either need another pair of sides or another pair of angles. What do I have? Yep, reflexive property. Starting to see how reflexive is really nice, friends. Yeah, so we know segment YW is congruent to segment YW by the reflexive property. Awesome. Now what do I spell on my triangle? Yeah, side, 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 exactly. So I know triangle. And again, make sure you match your vertices carefully. If I said triangle XYW, I'm going to match that to triangle ZYW in this case. And it's like what you guys told me, side, 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 congruence. Now notice I haven't did anything with my angles, but because I know those triangles are congruent, what do I know about all pairs of corresponding angles? They're congruent. So can I go to my very last step? Yeah, so therefore, angle XYW is congruent to triangle. Wow. All right, angle ZYW by, that was a little quiet, but yes, it was Cpctc, which stands for what? Go.
Corresponding parts of congruent triangles are congruent.
Excitement overwhelms me right now by you guys. All right, wonderful. Help me out. Should we be able to rock this next one out pretty quickly, you think? Yeah, especially if we mark up our diagram and visually just write down S or A. It's a lot of times we can see how these triangles are proven. And some of you are already working ahead because like, I got these, right? I got these. All right, first thing you always do, start with your what? Given, very good. So we got segment PR bisects angle QPS and angle QRS. How many pairs of congruent angles should I get out of this? Two, right? Because do I have two different angles being bisected? It's that one segment's doing it for two different ones. So if I look at QPS, these two would be my congruent angles. So I got angle QPR is congruent to angle SPR. And then what other two angles? I'm going to put in the same steps since I had the same reason to start with. So you said which one? Yep, QRP, yep. QRP is congruent to angle SRP. And this definition of what type of bisector? I did. Yep, I agree with you. Yes, yes you can. All right. Yep, I have two pairs. So guys, I have here an angle and an angle. I have to have a what? You can't have congruent triangles unless you have at least one pair of congruent sides. Where is it? Yeah, segment PR, right on. So segment PR is congruent to segment PR. That's your reflexive property. Oh, what does that spell? Angle, side, angle, right? Yes, ma'am. What? Why would you need to, though? Then, yeah, then you would have another angle, but there's just not a need, right? Then you could do angle, angle, side, but that's just more work than you need to. I would just leave it right here. I only need 3 pairs of corresponding parts to make a triangle congruent. So I have those now. So my next step is just going to be that. Triangle PQR is congruent to triangle PSR, making sure I matchy-matchy. Every vertice has to go together. Guys, what's my reason? Yeah, angle, side, angle, congruence. Now, if those triangles are congruent, what do I know about segment PQ and segment PS? Are they corresponding ones? Are they corresponding sides? So they have to be what? Congruent. All right, guys, what's my reason for them being congruent? What are my lovely initials? Which stands for what?
Corresponding parts of congruent triangles are congruent.
You're all doing it, but you're fading, friends. You are fading. That's good job. Corresponding parts of congruent triangles are congruent. All right, I'm hitting pause on this, and then we'll talk about it in a little bit. I'm going to start putting the proof in here, guys, while you guys are still finishing up, just so we're all about to the same spot, because most of you said you got to yourself to the point where you had at least the triangles congruent, right? So first thing was we had segment NO is parallel to segment MP. Guys, if I have parallel lines, should I either get congruent or supplementary angles somewhere? Which one am I going to use in this case if I'm trying to show congruent triangles? Congruent angles, right? Are those two angles congruent? Right? Alternate interior. So that would be what I'd put next. So I'd say angle NOM is congruent to angle PMO. And that would just be if I have parallel lines, then alternate interior angles are congruent. And if you wrote the name of the theorem down, it's the alternate interior angles theorem. All right, so I have that down. Then I can go back to my given, and I got segment NO is congruent to segment PM. Oh, that's given. Guys, that gives me a pair of sides, a pair of angles. What do I need? A side or another pair of angles. At least one more thing, right? We're 2 out of the 3. Looking at the diagram, what's the one thing I can get no matter what? Reflexive property. So I can get the side. So I can use a little bit of attitude, some sass, right? So with that one, we know segment MO, and again, remember, I'm switching this around because I'm matchy-matchy right away. Segment MO is congruent to segment OM by the reflexive property. And again, we've said this in the past. If you said OM is congruent to OM, I would still give you full credit. I'm just doing this because it matches it up. Now, I know the triangles are congruent. So I have triangle. Let's go. NOM is congruent to triangle PMO by SAS congruence. Great. Now guys, how do I prove lines parallel? Because remember, I'm trying to get to lines being parallel. No, that doesn't prove that they're parallel though. To prove lines parallel, don't I need pairs of congruent angles or supplementary angles first? Right? So remember, the two that I'm trying to show parallel, I'm trying to show these two parallel. I've got to show something. If this is going to let me do it. You guys agree with me that's true? Why do I know those two angles are true? What is it again? Exactly. Guys, remember the whole point of getting triangles congruent so I can pull out the parts that are congruent, right? So the fact is, I know angle NMO is congruent to angle POM because everyone all at once, what is it?
Cpctc.
Which stands for?
Congruent.
We pause for 5 minutes, people mess it up. All right, guys, what does CPCT stand for? Go.
Corresponding parts of congruent triangles are congruent.
That was better than a couple times before, so that's much better. All right, so I make this Z shape with my congruent angles. What does it mean my lines are? Yep, they're alternate to your angles that make my lines what? Parallel. Very good. So now I can sit there and end. So segment MN is parallel to segment OP because if alternate interior angles are congruent, then parallel lines. What do you guys think? Think you guys can do these? Yes. So sometimes if it's not proving a pair of congruent sides or angles, no, you're going to have to go a step further. All right? You're going to have to go one step past CPCTC. Yes, ma'am. That's totally fine. That's totally fine. All right. What I'm going to do is I'm going to pass out your quizzes while you guys are loading on your surfaces your homework. All right, Tyler, let's get yours out and let's hope and pray this works.